Protein powders are everywhere, from gym bags to morning smoothies. They're becoming a part of many people's daily routine, but are they hiding a toxic secret? On October 14th, so just last week, Consumer Reports released new testing data showing that many of the most popular protein supplements contain measurable amounts of lead that exceed their internal benchmark. Today, we're breaking down what they found, what it means for your health, and how those numbers compare to actual regulatory and toxicological limits. This is Daily Value, and I am your host, William Wallace. Last week, Consumer Reports released an investigative review led by journalist Paris Martino. I apologize if that's a mispronunciation. Testing 23 protein powders and ready-to-drink shakes for heavy metal contamination. The results drew immediate attention. Over 70% of products contained more lead in a single serving than, and this is important, Consumer Reports' own daily safety threshold of 0.5 micrograms per serving. So what is Consumer Reports? Consumer Reports is an independent nonprofit organization known for product testing and investigative, I use that term loosely, journalism. It evaluates consumer goods from electronics to supplements using laboratory analysis and publishes its findings to inform public safety. The analysis covered plant-based whey and beef protein powders, many marketed as clean or natural. Among the top offenders was Naked Nutrition's vegan mass gainer with 7.7 micrograms of lead per 315 gram serving. That's equivalent to 6 scoops, more than 15 times Consumer Reports limit. Fuel Black Edition contains 6.3 micrograms of lead and 9.2 micrograms of cadmium per 90 gram serving, or 2 scoops. Garden of Life Sport plant-based protein measured 2.8 micrograms of lead per 45 gram serving, equal to 2 scoops, about 5 times higher than Consumer Reports benchmark. Across the dataset, plant-based proteins contained roughly 9 times more lead than dairy-based proteins. The difference Consumer Report attributed to soil uptake in crop and the concentration that occurs during drying and isolation of the materials. Compared with its last round of testing in 2010, this year's results showed both higher average lead levels and fewer products with undetectable contamination. These findings come as the protein supplement industry exceeds $16 billion in U.S. sales alone. But as the market expands, so too does the potential for trace contaminants that accumulate naturally from soil, water, as well as manufacturing equipment. The question is whether these findings indicate a meaningful toxicological risk or simply reflect the differing safety thresholds used by Consumer Reports versus federal and international regulators. To answer that, we actually need to look at what lead does to the body. The toxicology of lead has been studied for more than a century by different governments, scientists, and regulatory bodies, and it's important to note that the conclusion has not changed. There is no safe level of exposure. According to the Agency for Toxic Substances and Disease Registry, that's a branch of the U.S. Centers for Disease Control and Prevention that evaluates chemical hazards in the environment, lead affects virtually every organ system in the body. It mimics essential minerals like calcium and zinc, disrupting neurotransmission, mitochondrial production, and kidney function. Once absorbed, it's primarily stored in bone and teeth, where it can even remain for decades and then re-enter circulation later in life. When someone ingests lead through food, water, or supplements, only a fraction of that intake enters the bloodstream. In adults, about 10% of ingested lead is absorbed. In children, the rate can be 40 to 50%. That absorbed amount distributes throughout the body with a small portion circulating in blood. Over time, even microgram quantities can raise blood lead levels. For example, an additional 5 to 10 micrograms of lead intake per day, roughly what might come from a few contaminated servings of food or a high lead supplement, can sustain blood levels in the range of 2 to 10 micrograms per deciliter after weeks of consistent exposure. One of the most detailed analyses by Bruce Lanphier in 2005 combined data from more than 1,300 children worldwide. They found that as blood lead levels increased from 2.4 to 10 micrograms per deciliter, average IQ dropped by nearly 4 points. The effect curve was steepest at these low exposures, meaning that small increases at the bottom end caused proportionally greater cognitive loss than larger increases at higher levels. The European Food Safety Authority, or EFSA as they're called, functions as the European Union's independent scientific panel for food safety. Its 2010 report confirmed that lead follows a linear, no-threshold model, meaning that every incremental rise in exposure adds measurable biological risk. EFSA estimated that daily intake of 0.5 micrograms per kilogram of body weight per day could already contribute to neurodevelopmental harm in children, 0.6 micrograms to kidney effects, and 1.5 micrograms to high blood pressure. To put that in perspective, a child weighing 45 kilograms or approximately 100 pounds would have to take in, and it's important to remember these numbers, 22 micrograms of lead per day to be at risk for neurodevelopmental harm, 27 micrograms of lead per day to see kidney effects, and 67 micrograms of lead per day to see higher blood pressure effects. Now, to see those effects in an adult, you would essentially double those numbers and then consider that adults and children absorb lead at different rates. Remember, around 10% is absorbed in adults, and up to 50% can be absorbed in children. In the United States, the average adult blood lead level is about 0.9 micrograms per deciliter, which is actually down from 5 to 15 micrograms in the 1970s, and that's important to remember. But because much of that lead remains locked in bone, even low modern exposures can contribute to a long-term cumulative burden. As the Agency for Toxic Substances and Disease Registry summarizes, even minute amounts can initiate subtle cellular damage. So how do regulators decide what's considered a safe amount of lead, and why do the numbers vary so dramatically? Well, in the United States, lead levels for supplements are guided by the Food and Drug Administration, or the FDA, though the agency doesn't set an official legal maximum. Instead, it uses what are called interim reference levels. These represent the total daily intake from all sources that's unlikely to pose risk over a lifetime. The current interim reference levels are 8.8 micrograms per day for adults and 2.2 micrograms per day for children. The threshold used by Consumer Reports, on the other hand, 0.5 micrograms per day, comes from California's Proposition 65, a state law designed around the most conservative possible estimate of reproductive toxicity. It's a precautionary benchmark, not a federal safety limit, and it's about 20 times stricter than the FDA's guidance. In Canada, the federal regulator, Health Canada, sets a concentration limit rather than a daily intake value, 0.1 parts per million or 0.1 milligrams of lead per kilogram of product. If you apply that standard to a typical 50-gram protein serving, the allowable amount of lead would be about 5 micrograms, roughly similar to the FDA's daily reference. In the European Union, oversight falls to the European Commission, advised by the European Food Safety Authority, or EFSA, the same body that sets toxicological reference points. Under current regulation, food supplements can contain up to 3 milligrams of lead per kilogram of product, equivalent to 150 micrograms in a 50-gram serving. Now, that is what is allowed by the European Union and, again, advised by EFSA. EFSA's own scientific opinion is much stricter when expressed as an intake, about 0.5 micrograms per kilogram of body weight per day for neurological effects, 0.6 for kidney toxicity, and 1.5 for blood pressure increases. Remember these number values I gave for a child weighing 45 kilograms? That's 22 micrograms of lead per day to be at risk for neurodevelopmental harm, 27 micrograms of lead per day to see kidney effects, and 67 micrograms of lead per day for blood pressure effects. These discrepancies between countries exist because agencies use different frameworks. The FDA and EFSA base theirs on total daily exposure and toxicokinetic modeling. That means how much lead actually enters and stays in the body, while Proposition 65 focuses on worst-case scenarios and a one-size-fits-all threshold. Industry groups like the Council for Responsible Nutrition, which is a premier trade association that represents the dietary supplement industry, have criticized Consumer Reports' approach, arguing that using a private threshold not recognized by any regulator creates a misleading impression of risk. Still, the FDA's absence of formal supplement-specific limits leaves room for this kind of interpretive gap. To understand how these thresholds translate to real life, we need to look at how much lead people typically consume from ordinary food. To put these thresholds in perspective, it helps to look at how much lead people already consume from ordinary food. In the United States, the FDA's dietary exposure data and the Agency for Toxic Substances and Disease Registry toxicological modeling, they estimate that adults ingest about 0.2 to 0.8 micrograms of lead per kilogram of body weight per day. That's roughly 14 to 56 micrograms daily for a 70-kilo adult. For children, the intake is proportionally higher, around 0.5 to 1.5 micrograms per kilogram per day, or 3 to 10 micrograms total, because children eat more relative to their body size and absorb a greater fraction of what they ingest. In Canada, where historical data show a steady decline since the 1980s, average adult intake is lower, around 0.1 micrograms per kilogram of body weight per day, or 7 micrograms total, with slightly higher values for children. Across Europe, the European Food Safety Authority reports a wider range. Adults typically consume 0.36 to 1.24 micrograms per kilogram per day. That's 25 to 85 micrograms daily, while children average 0.7 to 1.8 micrograms per kilogram, or about 5 to 13 micrograms per day. The variation largely reflects dietary patterns and environmental factors, more cereal grains and root vegetables in Europe versus more processed foods and dairy in North America, but the overall pattern is consistent. Even with modern regulations, most people already consume enough lead through diet alone to reach a few micrograms per day. So when a single protein shake adds another 6 or 7 micrograms, that one serving can effectively double a day's intake for many adults and exceed the FDA's reference level for children several times over. To understand how that compares with everyday foods, let's look at what the FDA's Total Diet Study found. The FDA's Total Diet Study, or TDS, offers the best estimate of how much lead people ingest from food. It's a long-running surveillance program where the agency buys over 300 common grocery items, from milk to bread to chocolate and vegetables, prepares them as they'd normally be eaten, and measures trace elements like lead in parts per billion, which translates to micrograms of lead per kilogram of material it's being measured. The most recent report, covering the fiscal years 2018 through 2020, show that most everyday foods contain detectable but low amounts of lead, typically in the single-digit or low double-digit parts per billion range. Translating those numbers to what we actually eat, bread or rice, about 10 to 20 parts per billion, equal to 1 to 2 micrograms of lead per serving. Dairy products, 5 to 15 parts per billion, contribute about 0.5 to 3.5 micrograms per glass or slice. Cooked meats, 10 to 25 parts per billion, supply another 1 to 2.5 micrograms. Dark chocolate and some spices are higher, averaging 50 to 100 parts per billion, or 1.5 to 3 micrograms per serving. Juices like apple or grape typically fall near 1 microgram per cup. When you total it up, the average U.S. adult consumes around 9 micrograms of lead per day from food alone, already close to the FDA's interim reference level of 8.8 micrograms for total daily exposure. For children, the same foods scaled to body size contribute proportionally more. That context matters because a single high lead protein serving, like the 7.7 micrograms measured in Naked Nutrition's mass gainer, essentially doubles a typical day's intake. For a child, that one serving could triple their entire daily reference limit. That sounds scary, right? But let's also remember that that's coming from a vegan, so a plant-based mass gainer at 6 scoops per serving. That product is for a very niche audience that likely doesn't include many children. The takeaway isn't that ordinary foods are unsafe, but that trace exposure, it's unavoidable. The question becomes whether supplements meant to improve health should meaningfully add to that baseline. So, given those comparisons, are the levels found in protein powders actually dangerous, or are they being interpreted through an overly cautious lens? From a toxicological standpoint, the numbers sound alarming, but must be considered in context. A single serving of Naked Nutrition's vegan mass gainer at 7.7 micrograms of lead represents about 88% of the FDA's adult reference level of 8.8 micrograms per day. 2 servings would exceed that benchmark, but for adults, that still sits far below the exposure levels associated with measurable clinical effects. Also, who actually drinks vegan mass gainers? I don't know many people, and they're kind of gross. No offense meant. If you do, though, they're just not for me. For children, the picture changes. The FDA's child reference level is 2.2 micrograms per day, so even one serving of the higher lead products could triple or quadruple that amount. Because children absorb more lead and have developing nervous systems, their risk window is proportionally smaller. The European Food Safety Authority and ATSDR both note that daily intakes below roughly 0.5 2.6 micrograms per kilogram of body weight, are unlikely to cause overt harm in adults. That means a 70 kilogram person could tolerate 35 to 40 grams per day without exceeding those conservative thresholds. Most of the protein powders Consumer Reports tested, even the outliers, fall an order of magnitude below that range. Industry groups, including the Council for Responsible Nutrition, argue that trace lead in plant proteins is expected because crops naturally take up minerals from soil and water. Detection, they emphasize, isn't the same as hazard. From that perspective, the Consumer Reports 0.5 microgram level of concern is more of a precautionary flag than an actual toxicological cutoff. The balanced view is that occasional use of these supplements is unlikely to pose risk for healthy adults. The greater concern is chronic daily intake, particularly in children or people who are pregnant, where cumulative exposure could matter over time. So rather than panic over the numbers, the takeaway is actually quite practical. Choose third-party tested products. Avoid stacking multiple supplements that contribute to trace lead intake if you can help it, and vary protein sources across your diet. That's the same old sound and boring nutrition advice you would get from most reputable sources, for the reason that it still holds up even in cases like this one. To recap, Consumer Reports raised valid questions about heavy metal content in protein supplements. Their testing showed real variability across brands, but the health significance depends on how those numbers are interpreted. Most adults still fall well below harmful exposure thresholds, though children and frequent users should be more cautious. Also, let's be real, children shouldn't be drinking vegan mass gainers anyways. The broader issue isn't that protein powders are unsafe, it's that there's no unified global standard for what safe actually means. Until there is, transparency and third-party testing remain the best consumer safeguards. Thank you for joining me today on Daily Value. Until next time, stay healthy.